Okay, this is a run through of the May 2024 exam from last summer for Unit 1 Physics International A-Level, which covers the topics of mechanics and materials, which is also very useful for those studying the linear Edexcel in their build-up to their end-of-year exams, as it's the only paper that puts mechanics and materials together. The Edexcel linear tends to have mechanics and electricity in the same paper, which is probably better done later in the year. Okay, so if you're subscribed to my channel, thank you very much. If you haven't subscribed, please subscribe so you get notified when the next papers are uploaded. And if you've watched any of the videos, please make sure you give them a like and share them with your friends in your own schools. That would be great because it helps us with the YouTube algorithms. Okay, section A is a multiple choice, 10 questions. So this question is about an engine used to remove water from a mine. So it must be some kind of pump. The engine transfers energy to the water at a rate of 180 kilowatts. Okay, so that's the useful output, and wastes energy at a rate of 60 kilowatts. So the total energy input must be 240 kilowatts because it's useful plus wasted. Then they want you to see which expression gives the efficiency. Well, efficiency can be in watts divided by watts or joules divided by joules, so energy or power, they both work. So the useful output would be 180 divided by the total input, which will be 240. So the answer is A. So the first question is just warming you up. Easy questions, similar to GCSE. The only thing could be that you don't read the question carefully and you confuse the useful output as the input power. Okay, the graph then shows for question 2 how velocity of an object varies with time, which describes the motion of the object. Is it constant acceleration? Well, it's not, because that would be a constant steepness. It's not a constant gradient. Constant displacement, well, constant displacement, the displacement's the area. Yeah, and obviously this is going up with time, so it's not a constant displacement. It's the area under a velocity time graph gives you the displacement. A decreasing acceleration would be one where the gradient is decreasing, which is exactly what we have. So C looks like it's the correct answer, and D would be a decreasing displacement. Well, it's not, it's an increasing displacement. As time goes on, the displacement increased with time. Okay, so the answer is C. Question 3, an object is moving through a fluid. Which row of the table states the conditions which must be met for Stokes' law to apply? So if you've known Stokes' law, you know it should be a small spherical object and the type of flow should be laminar, so it has to have 3 ticks and it has to be C. Okay? Number 4, which of the following expressions gives a vector quantity? Density times volume is mass. Well, that's mass is a scalar. Force times distance moved in the direction of the force is the work done or energy used, and that's a scalar. Energy is also a scalar. Mass times velocity is momentum, and momentum is a vector, so it's C. Power times time gives you energy, and energy is a scalar. Question 5 and 6 refer to the same information in this graph. A student stretches a spring of original length P to a length Q, so you can see that it's gone from P to Q on the length. Therefore, P is the original length. The graph shows how the length of the spring changes as a student increases the force from 0 to R. Okay, so which expression could you create to give the stiffness? Well, the stiffness is K in the F equals Kx Hooke's law equation, so K must be the force over X, which is the extension. F is the force applied, so that's R on this graph, and extension is the difference in length, which is Q minus P, so the answer is R equals Q minus P, which gives you the answer D. Nice, easy question from the materials topic. Question 6 also applies to the graph. Which expression gives the work done in stretching the spring from its original length P to length Q? Well, that's the area under the graph, which will be half Fx, which will be the area from P to Q. So it would be, if I shade it in for you, it will be the area of this triangle. So that's what you've got to work out, which is half the base, which is half R times P minus Q. Half R times Q minus P, which gives you B. Okay? If you can work that out. Question 7 is a knowledge question. Which of the following describes the center of gravity of an object? Well, you can read through them all, but I'm going to go straight to the answer. It's the point where the weight of the object may be considered to act through. I always like to say act through, because it is acting through that point. Okay? So that's a knowledge question. D. And number 8 is determining the acceleration of free fall, which is the core practical one, which we couldn't do because we got the wrong timers. Hopefully they will arrive shortly over the Christmas period. The student uses a stopwatch to measure the time taken. So T, for a ball bearing to fall a measured distance S. Okay, the student calculates so the student calculates a value of G, I should say, that is greater than 9.81 meters per second squared. So in other words, the acceleration went faster than the true value of G, but why would that happen? Which could give an explanation for the wrong or the high result obtained by the student. So we'll have a look. The answer is A, so let's see why B, C, and D aren't correct. A says the ball bearing is moving downwards when the student starts the stopwatch. So he's underestimating the time, and if he underestimates the time, acceleration is change of velocity over time taken. If the denominator is too small, the acceleration will be too large. In the second one, the ball bearing is moving upwards when the student starts the stopwatch, which is debatable. So I put a double question mark there, but if that happens, time will go up and it will give you the opposite to what the student obtains. Likewise for C, if the student starts the stopwatch before the ball bearing is dropped, then his time reading will be greater than it should be. So if the denominator increases, the acceleration should decrease. So it gives you the wrong value. And D, the student stops the stopwatch after the ball bearing lands. So again, he overestimates the time, and if he uses that in the equation, it's the denominator increases, acceleration will decrease. So the only way to get a higher than expected acceleration, the explanation should be A. Okay, so we want to put A in our multiple choice answer, which I've forgotten to put. Question 9, I must say, I looked at this question and I didn't like the mark scheme on this. I felt that although the answer is correct, the explanations lacked a little bit of detail required for students to understand it. And that's the problem when students use the mark schemes. The mark schemes are written for the examiners. They're not written for students, and sometimes they don't explain why the answer they've given is true. And I couldn't understand what they were writing in the mark scheme in terms of their reasoning. Anyway, the answer is B, but let's have a look and see. A student attached one end of a wire to the support and added masses to the other end of the wire. As shown, the student measured the corresponding extension for each added mass. The wire broke when the extension was small. Okay, so if the extension was small, the wire must be weak, so the wire could be thin. The student then replaced the wire with a second wire made of the same material, so it's nothing to do with the material. The second wire had a larger extension before breaking. Well, which one could produce this result? Well, the answer is B. If it had a longer length, each portion of that length would feel the same force. So it's like having lots of springs in series. They all extend by the mass that they are carrying. So you would proportionally extend the total extension will be increased. So the answer is B. And the second wire, so A says the second wire had a greater diameter. Well, if it had a greater diameter, it would extend less for the same mass. But they haven't clarified. So I'm assuming that we're using, as comparison, we're using the same amount of mass to be valid, to make the experiment a fair test. They haven't explained exactly what the conditions are. So they haven't said that they're using the same mass, so we have to assume they're using the same mass. So if they're using the same mass with a greater diameter, it would be like you got springs in parallel and they all share the load, so it would extend less for the same mass. But we don't know when it would break until obviously it would take a bigger mass for it to break. But I don't know what extension would occur. It's quite complicated if you go into A too deeply. And C said the second wire had a smaller diameter. Well, if it had a smaller diameter, it would break easily, so it wouldn't extend more. So I don't think C is the correct answer. And D, the second wire had a shorter length. So if it's a shorter length, it would not extend as much. So really the only reasonable answer is B. But as I said, the explanation in the mark scheme given is inadequate, in my opinion. And I've checked with my colleague, and he agrees that there is a lack of clarity in the mark scheme. So this is why I do the YouTube channel. So I try to explain to students how to answer questions and not to rely fully on the mark scheme. Okay, it is the explanations that you need to improve your thinking and your critical thinking skills. Question 10 is about a ship with a mass given as 1.2 times 10 to the 7 kilograms. So that's M. It has an acceleration of 0.03 meters per second squared. The force produced by the ship's engine is 8.0 times 10 to the 5. Which of the following expressions give the magnitude of the drag force in newtons on the ship? So that means the force that I've put 8.0 as F minus the drag must be the resultant force, F minus D, which is accelerating the ship forwards. Therefore, if you want to work out D, it would make D the subject of the equation. It would be D equals F minus MA, okay, which would be 8.0 times 10 to the 5, yes, minus 1.2 times 10 to the 7 multiplied by 0.03, which gives you the answer A. Okay, so that's the end of the multiple choice section. If you found it useful, give it a like, share it with your friends, and if you're one of my students, make sure you've done your corrections in time for next week's lessons. Bye for now. Catch you in the next video.